Well, today we're going to be taking a look at lesson 1.1, which is points, lines, and planes. Our objectives: identify and model points, lines, and planes, and then identify intersecting lines and planes. So let's start with a few definitions. Okay, a point is a location. So this is a kind of a fundamental understanding here. Point just being a location. It has neither shape nor size. So a point doesn't have any size, no width, no length. It's simply a location. Okay. In this example we see over here, we see point A, and to label a point or to describe a point, we write out point and we label it with whatever the letter of the point is. So that's in the example there. We use capital letters for points. Okay. A line, this next definition is a line, and it is made up, you guys have seen lines before in Algebra 1, a line is made up of points. Okay, it has no thickness or width, and there is exactly one line through any 2 points. So here, there's a couple of ways we can label, in this example we have out here, there's a couple of ways we can label the line we're looking at. Line M, we can use that lowercase, and we can write line M. It's kind of in that font there. We can also name it by 2 points. Okay, if you're naming a line by the points that it goes through, just use 2 points. You do need to use that notation where we draw the line with the arrows on either end above the 2 points. Okay, we've got to use that when we're naming a line. Any 2 points that are on the line you can use to name the line. Okay. Our next definition, okay, is called a plane. Okay, and a plane is a flat surface made up of points that extend infinitely in all directions. So if you kind of think about your desk when you're here at school, and just that surface of your desk, think of that as a plane. We'll now extend that surface in every direction infinitely, and that's kind of the best way to describe a plane. Even when we look here, it's kind of difficult to draw a plane on a piece of paper. They use this blue figure here to try and do so, but really this plane would extend. It would extend out this way. In every direction this plane extends. And so it kind of just goes on forever, and then there's points all over that plane. So to label a plane, or to know when we're talking about a plane, okay, you just call it plane and label it by the capital letter. This would be plane K. Or you can use any 3 points on it. So plane, we can use plane BCD in this case. That's 3 points on the plane. So a couple of ways to label planes there as well. Alright, let's continue. Here, another definition: points that lie on the same line are called collinear. Collinear points. Okay, they lie on the same line. So when we look back at this line, we already have looked at line PQ. We would say points P and Q are collinear when we look at that example. The next definition: coplanar points, okay, are those points that lie on the same plane. So in that example of a plane we had, we would say that B, C, and D, those 3 points, are all coplanar with each other. They all lie on the same plane. Okay. So here, let's use the figure to name each of the following. Let's go here with part A line containing point W. So let's first identify where is point W. So here is point W. Okay. A line containing that. So what line goes through point W? Okay, looks like, of course, this line I'll highlight there with blue. That is line N. So to answer part A, well, yeah, that's line N. Okay. Of course, you can name it using points that go through it. VW, any 2 points on that line. You could use VW XY, WY, any 2 points to name it as well, using the line with arrows above it. Okay. Part B, we want a plane containing point X. So let's identify here where X is. So X appears to be there. What plane does X lie on? Well, what plane is this here? Dropping my pens, apologize. What plane here are we on? This is plane P. Certainly X lies on plane P. Okay. Alright. So let's continue. The intersection of two or more figures. So the intersection, when these things start to intersect, okay, when we're talking about the intersection, we're talking about the points they have in common. Okay, common points are what we define as an intersection. So two important types of intersections you'll need to remember. Two lines intersect at a single point. If you draw any two lines that intersect, they would intersect at a singular point. This example with line L and M, where they intersect at point P. Okay. Another intersection you're going to want to make sure you make note of, the intersection of two planes, is a line. If you've got two lines, a good way to visualize this, take two pieces of paper, okay, and kind of put them together in a similar fashion as you can. Of course, you can't get a piece to go through the other piece of paper, but where these two pieces of paper touch each other, well, that would create a line R in this case. So two planes intersect in a line. Alright, so here's some modeling. So this is taking some real world objects here. We've got this cardboard, or this, this, not cardboard, what do they call those? Just kind of a bulletin board here with a postcard on it, and maybe a birthday card and some other things. And they want us to name geometric terms modeled by these objects in the picture. So let's just, like here you would want to come up with something that you could say models a plane, something that models a line, and maybe something that would model a point. Okay, so the plane, I think pretty easy. You think of a piece of paper as a plane. So you see this index card here. That models a plane. Okay, the index card, not card. Apologize there. What about a line? Okay, well, a line. Okay, here I see a line drawn. Line HJ, so that's kind of the edge of card, edge of the index card. And then lastly, what's a good representation of a point? Well, this is stuck into the bulletin board there with a pin, and so maybe that push pin or that thumbtack, we could say that's a pretty good representation of a point, kind of just a location. Alright, not any depth or width to the point of that tack. Okay. Here's some guided practice. Name the geometric term modeled by each object. You guys can go ahead and pause and think about this for a moment if you need. For 2A, what stripes on a sweater? What would that represent? Okay. Well, you gotta think stripes are linear, so this would be a line. And then corner of a box. Okay. Think about maybe one of the boxes you got for Christmas. Try to draw one here. And so the corner of this box, if we're just talking about one corner, that would be best represented by, I think, a point. So hopefully we got line and we got point. Okay. Let's continue. Things aren't wanting to load here. Okay. Example 2. So we want to draw and label a figure for each relationship. So here we're going to use this coordinate plane. Hey guys, coordinate plane. That's a plane we've worked with a ton in Algebra 1. A coordinate plane where you have x coordinates and y coordinates. Okay, these extend forever in all directions. It extends forever here That's why we have these arrows. They extend in every direction infinitely, x and y. So coordinate plane, that is a great representation of plane. All right, so let's talk about lines AB and CD intersecting at point E. So let's draw this. So AB, A is negative 2, 4. So that's point A. Point B is 0, negative 2. As best we can. I'm going to connect those a little better. Okay, looks a little better. And then let's do CD. And these lines are supposed to intersect. CD is negative 3, 0. So C and D is 3, 3. So there's line CD. They intersect at point E. So clearly these two lines A, B, and CD do intersect. They're telling us that point of intersection is E, which appears to be the point negative 1, 1. So there's the intersection of those two lines. And then it also says point F is coplanar with these points, but not collinear with A, B, and CD. So what's it mean to be coplanar? To be coplanar means you're on the same plane, so you're on the coordinate plane. Not collinear means not on either line. So just pick any point that is on the plane and not on either line. So you could say down here, F is coplanar. It's on the same plane. It's not on either line. So that takes care there of example 2. You guys pause. Go ahead and give example B a shot here. All right. So if you've tried this, we want to have that QR, and this is supposed to be line QR, intersects plane T at point S. So the best representation of a plane we've had is that parallelogram, which I didn't do a very good job of drawing one. Okay, let's call that plane T. It kind of extends in every direction. And then we want a line QR that intersects my plane. So let's draw point Q. Point R below it, because this is going to go through my plane. And best way to represent that is using a point on the plane that's showing that it goes through it. That point that it goes through the plane would be point S. Kind of think of this as, you think of your line kind of as an arrow. If you put an arrow through a piece of paper, certainly there would be a single point where that arrow is still touching the piece of paper. Okay, that intersection point. Okay, let's continue. Okay, space. We're going to talk about space now. Space is three-dimensional. Okay, so space is the boundless three-dimensional set of all points. It contains points, lines, and planes. So space is the way we describe 3 dimensions. Okay, our classroom is a space. It has 3 dimensions. It contains numerous points, lines, and planes. Example 3. So here, how many planes appear in this figure? So here we're just counting the number of faces we have. So we've got this plane X. Okay, I'm going to use black. And then we've got this face of the triangle, or that triangular face. That's a plane. So we've got this plane is 1. I'm going to make tally marks. That face, 2. I see another face of this cone here. So that's 3. I've got that face on the back that they're trying to draw. 4. Another face over here that goes through K in the back. That's 5. And then I see 6 here if we connect that one. So I count 6 planes here. Yeah, 6 planes. Okay. Name 3 points that are collinear. So 3 points all on the same line. Where does that happen at in this figure? This line only has 2 points on it, so there's not 3 points that are collinear. If we look at this 3-dimensional figure here, we've got that line JKD. Those points all lie on the same line. So point J, point K and point D. Those are all collinear. They all lie on that line there. Name the intersection of plane HDJ with plane X. So where two planes intersect, recall that's a line. So we gotta find that plane HDG first. So where is HDG? H to D to G. That is that front face. That's plane HDG. Kind of highlight it with green. Where does that intersect plane X? So plane X is this kind of parallelogram looking plane here. Those intersect here. I'll use red even. They intersect here. Okay, at what line is that? That's line HG. So we've got to label that one with points, so we got to use our line above it with arrows there. And then where do LM and EF intersect? Explain. So LM, where is LM? Did I gum up my picture too much? No, okay, I see LM over here. There's LM. And the other line, EF, where do they intersect? EF would be this here. There's no clear intersection here. This being a three-dimensional space, this line could zoom right in front of LM. So there is no, they do not intersect. Three-dimensional space, you can have lines all over the place that do not intersect. Okay. And then we got a couple more questions here, and our points E, D, F, and G coplanar. You guys take a look and try to answer these next two questions, and then about the intersection as well. And then your assignment, your page 8 from the textbook, 1 through 12 all. Of course, we're going to spend time in class working on those 12 problems. So thanks for watching your first notes video. Have a wonderful afternoon.